Okay, welcome back. And so today we're going to do another example. In this video we're going to show another example of graphing a reciprocal function. And so again, going along the lines of transformations and the basic functions, we treat this reciprocal function as another basic function in our toolbox that we can use to help us graph other functions that are similar. Okay, so here we've got 2 divided by x plus 1. Now notice it looks similar to a reciprocal function, except we're multiplying by 2. So if you wanted to rewrite this to see it better, we could rewrite this as, well, let's make this g of x. Let's make that g of x. We can rewrite this as 2 times 1 over x plus 1, right? And so we could write this as what? 2 times f of x plus 1, right? Because all we're doing is we're replacing x with x plus 1. So we could write this like that, okay? If that helps you see that this is a transformation, okay? So what is this doing? Well, we're taking f of x and we're multiplying by 2, so we're doubling it like in the last example, in the last video. But also this is a what? It's a translation, it's a horizontal shift by 1 unit to the left, right? So let's start with this, okay? So we know that we're doubling the point. So again, remember what points that goes through. It goes through 1, 1 and -1, -1, okay? But since we're multiplying the y values by 2, we're doubling them, then we know this is going to go from 1, 1 to 1, 2. And this is going to go from -1, -1 to -1, -2. Okay? Now, what about the shift? Well, we know that this is a horizontal shift to the left 1 unit. Now, everything is going to move 1 unit to the left, including the vertical asymptote. Right? So normally there's a vertical asymptote through what? X equals 0. Well, now that's going to move over along with these 2 points. So this point is going to move 1 unit to the right. Let's do it this way. Or to the left. And then this point is also going to move 1 unit to the left. And the vertical asymptote is also moving 1 unit to the left, and so it's going to go to x equals -1. And so now, if we put this together, we know that, oh, by the way, the horizontal asymptote is still the same, right? Still at y equals 0. And so now, when we put this together, with the way we know how the reciprocal function behaves, we know it's going to be something like this. And we're done. Now we can look at the domain. Okay, so in this case here, how does the domain change? Well, now the domain is everything except x equal to -1 because the vertical asymptote moved, right? So now we know that the domain is going to be everything from -infinity to -1 union -1 to +infinity, or again, we can write it in set notation and say all values x such that x is not equal to -1. Okay? And then likewise with now the range doesn't change. The range didn't change. So the range is still going to be from -infinity to 0, union 0 to positive infinity, or again, we could write it as all values y such that y is not equal to 0. Okay? Again, don't write both of those. You can either write it this way or this way. Don't write both of them. Okay? Now, what about the behavior as far as increasing, decreasing? Now, in this case here, this is decreasing on the entire number line. Because as you, again, move left to right, look what's happening to the graph. It's going down. And then what happens when you get to the other side of the asymptote? Boom, it flips up here, but it's still, as you move to the right, it's going down. So this is decreasing everywhere. Okay? So, well, not exactly everywhere, but it's decreasing. It's not increasing anywhere. So we would say this is decreasing, right, on the interval from negative infinity to negative 1, and from negative 1 to positive infinity. And there you go. There you have it. Okay, so there's example number 2. Again, make sure you practice these and understand the reciprocal function, especially when it comes to transformations. It'll be very helpful. Okay, have a great day.